Alright, here's section 4 example problems where now we're getting into probability. So this question says, which of the following values cannot be probabilities? We have all these different numbers here. Is to realize that a probability must be a value between 0 and 1. So it can be any values in between here, and it can include 0 and 1. Not be, in this case, probabilities cannot be negative. And if you take the square root of 2, you'll see that that's a number larger than 1. So that cannot be a probability either. It can be a 0, it can be a 1. 0.05 is actually a value between 0 and 1. And 3/5, if I change to a decimal, is 0.6, which is between 0 and 1. Alright, if one of the subjects is randomly selected, what is the probability that the test results in a false positive? A false would say that, here's our positive, that would be false is the subject is not a drug user if the test resulted and said they were. So out of the total number of all employees in this test, and so if I add up all of these, that gives me my denominator, 1 out of 84, or I change to a decimal and round for my probability. Who would suffer from a false positive result? Certainly the person tested would suffer because he or she would be suspected of using drugs when in reality he or she does not use drugs. In a test of a gender selection technique, results consist of 261 baby girls and 269 baby boys. Based on this result, what is the probability a girl born to a couple using this technique? We take the number of times a girl was born and divide by the number of total. So the number of times a girl was born, 261, over the total, add the girls and the boys. I get my fraction, and I just simply put that in my calculator and divide to get my probability. And remember again to look at this and logically say, does that make sense? It is a number between 0 and 1. Alright, does this technique appear effective in improving the likelihood of a baby girl? No, because improvement would be something over 50%, because you would guess half the time you'd get a girl, half the time you'd get a boy, or 0.5, and this is actually below that percentages, so it certainly does not improve the likelihood. Alright, below are the outcomes that are possible when a couple has 3 children. So in other words, this first row says the first child born is a boy, the second's a boy, the third's a boy. Second row would be the first child's a boy, second's a boy, third's a girl, and so on. What is the probability of exactly 0 girls out of the 3? The way to get 0 girls means they're all boys. So there's only one way out of 1, 2, 3, 4, 5, 6, 7, 8 different outcomes. So 1/8. What is the probability of exactly 2 boys? Well, we find each one of these 1, 2, 3 ways that they can exactly get 2 boys out of, again, the 8 children. What's the probability of exactly 1 girl out? Well, I see 1, 2, 3 ways to get 1 girl out of the 8 different outcomes.